Hello and welcome to Matt's Automotive Channel. This is for the 2013 Ford Taurus SHO 3.5 liter EcoBoost motor. And we bought this car knowing that it had a motor problem. We didn't know how bad it was at the time, but since then we completely tore it down and it's a complete loss. So my son bought a 3.5 liter EcoBoost motor out of a F-150 and he was told that it would work in this car. Well, after tearing and comparing the two motors, it absolutely will not work in this car. It's completely different. The heads are completely different. The high pressure fuel pump's completely different. The intake's completely different. The block is different where the turbos mount. The little return lines are different. It's just a completely different block. Not to say that it couldn't be made to work. It probably could if you wanted to put enough time, work, and money into it. However, it's just not going to be worth it for us. And then on this other motor that we pulled out of the Taurus SHO, we tore it completely down. It had significant engine damage. Basically, one of the pistons had blown apart and completely destroyed the whole motor. We got metal into all the bearings, the main bearings, the rod bearings, and everything is destroyed. And as you can see here, it chiseled away some of the inner portions of the cylinder wall there. And it's totally gone. We got metal distributed throughout the motor. It got into all the bearings. Here's one of the main bearings. You can see that thing's pretty much toast. The crankshaft here, let's see, here's the journal here for cylinder number 5. It got toasted too. Complete engine failure. And you can see in the previous video all the carnage and whatnot. Here's the bottom of the oil pan. You can see all the chunks that came out. One thing I didn't show in the previous video were the valves. I did go ahead and pull apart the cylinder heads to see if they were salvageable. And here's the valves for cylinder 5. You can see, yeah, it got bent. Both of the exhaust ones got bent pretty good. So, and then there's some chunks on the under portion of this head here where the metal and debris from that cylinder got slapped around and chunked out some of the bottom parts of this block. The whole block is bent. This one here, this is the intake on the left side. It spins freely. And however, this one, it's kind of difficult to turn now, and that's because the head is warped here on the exhaust side, probably from excessive heat. It's a few thousandths out, so it's very difficult to turn because basically this head is actually trying to bend the crankshaft. And I did put one of these beam style torque wrenches on it just to see how difficult it was. And yeah, putting it in here, it took about 10 inch-pounds to turn it. This one, it wouldn't even read anything. It's way less than 1 inch-pound. And on the other head, it's just the opposite. The exhaust turns fine, but the intake, it's really messed up. I don't even have the cam caps on this and I can barely turn it. It's probably warped this way as well. So anyway, one of these spark plugs got completely destroyed. The injectors, I thought, at least in cylinder 5, would be destroyed, but I think it's good because they're a little bit recessed in the head. But regardless, these heads, not to say that they couldn't be reused, but it would take a lot of work. You would have to rebend them and resurface them. It's just not worth it. So anyway, where does that leave us? Well, it's going to leave us buying another motor. We're going to have our third motor in here pretty soon. I think we're going to put this one up for sale. This is the one out of the F-150, and then just sell that back and hopefully recoup some money. The engine that came out of the Taurus, it's completely shot. Now, one of the questions is the motor that we're getting, it has, I think, 81,000 on it, and depending on how it was treated in its life, it could be really bad or maybe okay. So I'm not sure exactly what we're going to do with that motor. It may be that we kind of disassemble it and then kind of rejuvenate it, putting in new piston rings and new bearings and that sort of thing. We'll just have to wait till we get it to see it. So anyway, I'm just kind of sitting here in limbo at this point, and that's kind of one of the reasons I took the time to pull the heads apart and look at the valves and everything, even though I knew it was going to be pretty much a loss. So anyway, we're just at this point waiting for the new motor to show up, and we'll just take from there. Well, here's our new motor, just arrived today. So yeah, we'll have to get this apart here and see what kind of condition it's in. And we got to get that one sold, and this one probably send it to the recycler. Interesting how they packaged this one up. The truck driver wasn't very happy because the pallet is just too narrow for both forks of a forklift or even the little hand trucks they have, so we kind of had to balance it on one to bring it in here. Looks like the motor's kind of on its side. Kind of interesting how they did this. Let's go ahead and get this thing unpackaged. Well, there's how she sits on the crate. Kind of interesting how it was loaded on here, kind of on its side. So anyway, let's go ahead and get the crane out and hook it up and get it onto the engine stand over there. Actually, I think I'll probably pull off that flex plate first. Okay, let's see if there's any signs of leakage from this rear main seal. Actually, it's pretty dry there. Looks like it's kind of interesting. It's darker right here, as if though something had leaked, maybe from the transmission side of this car. I don't know. So anyway, looks okay. But since we have this off, we'll probably go ahead and replace the rear main anyway. It'll never be easier than now to do that. And well, first thing I noticed, it's real obvious they didn't make any attempt to save the wiring harness. They just cut it here. They left pretty much all the sensors intact, and then the main portion of the wiring harness, they just hacked it there and took it off. So we're gonna have to reuse the original wiring harness, which is fine, it's not a problem. But it's kind of interesting that they just chose to hack it all off. The other thing that I noticed here is that there are no lifting hooks on this engine like there were on the ones that we took out. But it looks like they lowered onto this pallet using an old seat belt that they just tied on here. So I have the lifting hooks from the other motor, so I think I'm just gonna go ahead and bolt those up, and then we'll use that with the crane to transfer it over to the engine stand. Looks like they just went ahead and took the turbo off and then hacked off the oil return line right here. Interesting, it could have just easily been pulled out. There's just a couple O-rings in there that kind of hold in. It's kind of just a friction fit. They just kind of just tore it out. It's kind of weird how they did this. Because if they had just pulled that out with the turbo, they could have sold the turbo along with the oil return. Now everyone who gets those turbos are gonna have to get new return lines. And wow, look at the rust on these headers here, on these header bolts anyway. It's just crazy. Makes me wonder if this just sat outside for a long time uncovered. Well, after checking out the turbos, we have one turbo that's in perfect shape. There's absolutely no axial end play here. There is always a little bit of radial end play, and that's normal, especially with journal bearings, because it's that layer of oil between the bearings is what stiffens this up. But you really shouldn't have any axial, which is the in and out play. This turbo is fine, and the other one had about 3 thousandths worth of end play there. So it's still within an acceptable range. I think it's good up to around 10 thousandths, and at that point, the turbines here start to hit the housing, and then you can have a catastrophic failure. But there's still a lot of life left in this one, so I'm going to leave these alone. And now turning our attention to the new motor. This is out of the Ford Flex. I'm debating what I should do with this, whether I should tear it down at least somewhat and put a new water pump in it, since that's kind of the Achilles heel with these motors. I also kind of want to check the compression. That's a little difficult to do with it out of the car, but what I can do is do a leak down on each of these cylinders and see if we have any excessive leaking, either through the piston rings or the valves and that sort of thing. And I think if this looks good, what I'm gonna do is probably just put it in as is. Just bolt up those turbos, put it on, and send it. Now what I did do is I did put a breaker bar on here and then turn the crank, and it actually spins fine, and I feel a lot of compression when turning it. So I have a feeling that it's gonna do pretty good. But just for that extra assurance, before I go through all the trouble of bolting this thing back together and putting it into the car, I definitely want to do a leak down. And the other thing I did was I pulled the spark plugs out of here, and I put the borescope down there and looked, and all the pistons looked pretty good actually. There was not a whole lot of carbon buildup, and they all looked pretty consistent. The only thing that wasn't consistent was the spark plugs. And here are the plugs, and I did label them as I pulled them out. So over here I got 1, 2, 3, 4, 5, 6. And if you look here, they all look pretty good. There's nothing crazy going on here, but on number 5, you can see that It's very white. There's not much darkening at all on that ceramic. Boy, let's see if I can get that in focus. You can see it's extremely clean, which is an indication that it's maybe burning a little bit on the lean side. But that's really the only thing that I could find. Everything else looks pretty good and pretty consistent. All right, got all the equipment hooked up here, and you can see our leak down here. It's actually a little less than 5%. Looks like maybe 3 or 4%. I've never seen a leak down that good on an engine before. So if all the other cylinders are like this, I think I'm pretty much going to leave this thing alone. Okay, now we're hooked up to cylinder number 2 here on the compression stroke, top dead center. And now it looks like our leak down is probably around 15%, which is significantly more than cylinder 1. However, that's still not bad. So the question is, where is the air coming out? And I listened here for the intake, nothing, exhaust, nothing. And then I pulled the dipstick right out of here, and guess what? I feel air coming out of here. So that tells me that that air is passing, getting past the piston rings. So that's where it's leaking. Okay, cylinder number 3, leak down about 15%. Cylinder 4, about the same, right there around 15%. Now we're on cylinder 5, looks a little better there, right around, looks like 11%. Okay, cylinder number 6, and looks like we're right around 9% leak down. Well, one of the things I see immediately that we're gonna have to deal with is gonna be this oil filter housing. As you can see, it looks like it's been leaking. There's a lot of oil residue that's been caked up on here. I'm still debating whether or not to do the water pump. I know it's never gonna be easier than now, but it does reside behind this timing chain cover. So you gotta take all that off. You gotta take the timing chain off, and it's a fair amount of work to do. Now, right here on the left side of the block, this is the weep hole for the water pump. And it doesn't look like anything's been leaking out of there. Well, let's go ahead and pull off this oil filter housing and see what the condition of this gasket is. Okay. And, oh yeah, that's completely flat. There's no more elasticity to this. I can tell it's gonna crack and break as soon as I pull it out. This gasket definitely needs to be replaced. Okay, with the oil wiped off of this, you can see how incredibly flat this is. It's definitely not gonna seal. Next thing to determine with the oil filter housing off is, do we need to replace this oil pan gasket? I do see some oil residue along the bottom here. However, I don't really see, it does not appear to be leaking here from the gasket. It was probably coming from this oil filter housing and dripping down and getting onto this. As you can see, the bottom side looks a little oily as well. And let's see, let's move over here, take a look at the other side. Crank this thing over. And what do we got over here? It does appear to be a little oily here. Looks like maybe this was resealed at one point. I see some RTV. That's definitely not factory. Also, as I look at the timing chain cover here, I see excess amounts of RTV. This is obviously not factory either, so this has been off before. And of course, when you pull this timing chain cover off, you always do the water pump. It's just a no-brainer at that point. So it's probably a safe assumption that that water pump has been replaced. So again, it strengthens the argument not to tear this open and replace it. This looks like a new seal here with the RTV. So we may be okay. There's also no apparent seal problem with the rear main seal here. I don't see any oil residue. Yeah, I think we're just gonna do the bare minimum here and then put this thing back together. Well, this engine seems to be in pretty good shape, so I don't really think we're gonna do anything as far as tearing it down. We'll pull off some of the old stuff here and then start putting on the new stuff. If it's in better condition from the old motor, we'll transfer it over. One of the things obviously is going to be this wiring harness. This is in bad shape and it's all hacked up. And also these exhaust manifold headers are in really bad shape. They're really rusted over. So I think we'll transfer over the old ones from the original motor to this block, and then we can go ahead and start reassembling everything. Well, we have our new oil filter housing gasket to go in here. There's the part number if you're interested. So I might clean this up a little bit. So I think we'll go ahead and put this gasket on and bolt it back up. And then these exhaust manifolds are pretty bad on this motor. So I think we're gonna put the original ones from the motor that we removed on here. They're just in better shape. And then we'll go ahead and replace the wiring harness. That'd be the next thing to do, because there are some spots here that are kind of tricky, like right over here for this crank position sensor, that if you don't get that on before you start bolting the turbos, it's going to be very difficult to get that on. So I really believe the wiring harness will be the next step. So anyway, let's go ahead and get started on that. Let's pull off this old exhaust manifold. Boy, these are really rusted on here. Get these on my, there we go. There we go. It looks like only one of the studs stayed in. This is real typical, and that's because the heads are aluminum, whereas the nuts that go on here are steel, so the steel rusts to the steel. So this becomes bonded pretty good, and of course the weakest part is where the stud goes into the aluminum, so it usually threads out with less resistance. All right, let's try to scrape away some of this buildup here. You gotta be real careful, because this is a aluminum head and it's very easy to gouge and scratch this. So if you do use something like this, a metal kind of blade to scrape this off, be real careful. Don't apply a whole lot of pressure. You definitely don't want to damage the head. If you use any kind of power attachment, get something that has a soft bristle so you don't gouge into the aluminum. As you can see, I'm using a soft bristle here. You don't want to use anything hard that's going to gouge into the aluminum. It's, again, very easy to scratch. Also, you're not looking for perfection here, but just get the main debris off here and just make sure that it's really flat, so when you bolt up the exhaust header, it doesn't hang up on anything and create a little gap or leak. One word of caution here: when you do this, make sure you plug up any of the orifices and that you don't want debris to fall into. As you can see, I've already kind of messed up here where the oil filter housing goes. Some of this debris is kind of going down in here, so I'm gonna have to make sure that this is really clean. I should have taped that up ahead of time. Yeah, this is actually one of the worst places to get debris, is right into your oiling system. Gosh darn it, I wish I'd just taped that up ahead of time. All right, I went ahead and scrubbed up the old gasket a little bit, and you can see that's much better compared to what came off anyway. So anyway, I'm gonna just go ahead and reuse these gaskets along with the old manifold, and hopefully this should work just fine. All right, so I went ahead and pulled off the nuts off the studs, so we'll go ahead and put these studs back in here. The end of these have a hex configuration, so you can use a 5mm socket to thread them back in. Just snug is good enough. All right, let's put our gasket back on here. All right, now let's transfer over our original exhaust header. Next, let's get our oil filter housing on. I cleaned up the surface area really well here, and then also the main surface on the block. Now we can just go ahead and put in our new gasket. And now we can just go ahead and bolt it up. Just torque these bolts down to spec. I just now received our new turbocharger oil return line for the right side turbo. So we can start focusing on getting the turbos back on. But first of all, again, I want to address this wiring harness, just simply because some of the parts that the wiring harness has to run through in the motor are very difficult to get to once you start bolting things up. So let's start taking this one off, and we'll put on the new one as we take the old one off. Okay, just grabbed the original harness off the old engine, and so anyway, we'll just kind of start replacing connector with connector, and make sure that everything's the same. Again, we're not 100% sure everything's going to fit perfectly, because again, this is out of a Ford Flex, and we have a Taurus SHO. Hopefully everything is the same though. Okay, the place that I'm going to start here is with this little shield here and the connector for the sensor for the crank position. Again, this I think is probably one of the most difficult sensors to get to, and also, yeah, you are going to have to pull this heat shield here to get the wiring harness out. So anyway, this is by far going to be the most difficult one, so let's start here. As you can see here, another thing that makes this kind of difficult is not only is this bracket just held on with some bolts here, but it's kind of multi-purpose. This bolt actually holds this other bracket on as well. So, and of course, once the turbo is bolted up, I mean, everything's gonna be bolted to this, and it would just be a huge mess. So anyway, this is definitely the right time to start addressing the wiring harness. Wow, fair amount of rust there. Wow, that was really on there. Okay, now we can go ahead and pull off this little heat shield. And as you can see, harness is kind of nestled right into there. Let's go ahead and disconnect the sensor. There we are. Okay. And wow, look at this. The wiring harness is even bolted onto the block right here as well. Let's undo this other bolt, get this harness off of here. Put this back right now so we don't lose it. And there's also another little fastener right here. Kind of pull that away. And I guess we'll take the original wiring harness and just start bolting that up as we pull the other one off. Okay, so look at this wiring harness. I guess this is the only part of the wiring harness that has like a little heat shield on it. So anyway, that looks like it matches up perfectly. However, this is a better connector. Too bad this one has already been destroyed. Tried to plug this new one in. I see there's a difference here, a couple of differences. Hopefully it's not going to be a problem. First of all, this old wiring harness actually has a little grounding point. I'm not exactly sure where that connects. Maybe it connects onto this stud right here. I'll have to look at the old video when pulling this apart. But the other thing is for the sensor here, for the crank position sensor, I tried to plug it in and you notice, hey, the connector is different. So wonderful. We already have differences here. Hopefully I can take the old crank position sensor off the old motor, put it in here, and hopefully it'll work, but I'm no guarantee there. We'll have to check in that a little bit closer. So again, we're just getting started here and we're already seeing some differences and some challenges. Okay, so we know anyway, we need a different type sensor for the crank position. Also, another difference here, if you look at the cam position sensor here, let me just take this one off here. Okay, I just slid that off. Again, you'll see it's a 2-prong. And look how it's oriented. It's facing downward. Now let's go over to the old head and take a look at it. Okay, right here, cam position sensor. Boom. Orientation is up, not down. And also, if we look in here, we see 3 conductors, not 2. So, I don't know if I'm going to be able to just pull the other sensor out, put these in, and have everything line up with the engine harness. Hopefully, we can just reuse these. To be honest, I'm struggling a little bit with getting this wiring harness on. Some of the connectors just do not match up. Just found another one that doesn't. These guys here are supposed to go to the coils. And if you look at these connectors here, there's 3 conductor. Look in there. Oh, only 2. So got one of the old ones and you compare it. Yep, there's 3. So we're gonna have to swap out these coil packs. No big deal, but it just makes me wonder what other inconsistencies that we're gonna find here. Let's start swapping these coils out. Yeah, physically, same dimensions, just a little different configuration for the electronics. So fortunately, those are gonna bolt in just fine with no problem. The wiring harness seems to be going on pretty good, with the exception of these things that I have to change. And right here, I just pulled the sensor for the cam position sensor. And let's see if you can compare these. They're a different diameter. The spacing between the hole and the sensor look the same, and also the diameter here, the O-ring, looks to be about the same. So hopefully we can just take this sensor and plug it in here. Let's see. Oh, let's see if they're the same length too. Let's see if it's going that far. Yes, they're exactly the same length, so I don't have to worry about it going in too far and actually hitting something. So hopefully this will just go in here. And yes, I can feel the O-ring sealing, so no problem there. Well, at least something's going right for us. And now our little 3-prong connector here should plug directly in there, so should not be an issue. Okay, good. Let's continue. Now let's just do the same thing for the other side. All right, so far everything's matching up really well. I think I've got all the connectors hooked up that I can do at this point, at least before mating it to the transmission in the car. So now I'll turn my head to the crank position sensor, and I just found it. And you can see here's the 3-prong one, so I'll remove the 2-prong and replace it and then plug that in. Well, I don't know why everything else is 8 mm. This particular sensor here uses a 7 mm bolt. Oh, let's go ahead and pull that out. And there we go. Now we can just drop in the one from our other car, and the wiring harness should then hook up. Okay, new sensor bolted in. Now we can plug in the wiring harness to our sensor. There we go. And then replace the little plug. To keep dirt and debris from getting in there. Now we can go ahead and bolt back in our little heat shield. Well, before we go any further, I discovered 2 other issues that we're going to have. One has to do with these reluctor wheels that go on to the end of the crank. It helped determine the computer what position the crank is in. There's some differences here. This is the one off the Taurus. This is the one off the new Flex motor that we got. The other issue that we're going to have has to do with this coolant pipe that fits down here below the intake. And the pipe that's currently here doesn't have this little chute off here. And so I'm probably gonna have to take all of this apart. Unfortunately, now that I got the wiring harness on, that's all gonna have to come back off. And we're gonna have to figure out how we can insert this in its place. Maybe we have to swap over the whole intake there. I don't know what difference is. I'll have to look at that a little bit closer. But really what I'm most concerned with right now are these reluctor wheels. And first of all, if you just look at the ends here, you're going to see that one has way more teeth than the other. The other thing that's a little concerning, if you look on the back side here, this little indentation here actually fits into the end of the crank, so it's aligned properly. However, if we take those 2 holes and line them up, like so. Go ahead and put a screwdriver down here. You're going to see that the open gap is in a different location depending on which wheel you use. It's over here in the one case and over here in the other. So it is different. One is not going to be interchangeable with the other unless the crank shaft is different. So really that's going to be the next thing that we need to figure out, is if the crankshaft on the Flex motor is clocked a little differently and requires this reluctor wing. Otherwise, we're going to have to replace the Flex one with the one that came off the Taurus. So anyway, we're going to have to dive into that a little bit more and see what's going to work for us. And why this is so important is that if the computer doesn't know the position of the crank or the proper position of the crank, the timing is not going to work. It may not even start. I don't know. So anyway, this is definitely going to be an issue that we have to address. I got the crankshaft out of the Taurus up here on end, so you can kind of see how this reluctor wheel fits on here. And again, this little protrusion here is going to coincide with the little hole here. That's what lines it up. So as you can see, I put it on here, and as I move it around here, it will click in there, so it only fits one way. Now it's locked into place. So what we're gonna have to do is come around here to the back side and then fit it on there. And I think I'll take out one of these plugs and then stick a little rod down into the cylinder, and then we'll rotate the crank until number one goes to the top dead center. And then we'll check the position of that little reluctor wheel once we have it onto the back. And then we'll do the same with this. Okay, so I got the coil and the plug out of cylinder one, and I put this little rod down here so I can see the position of the piston. So we're gonna move cylinder one to top dead center. So we can just observe this as I rotate it, and we'll know when it gets to top dead center. And we're top dead center right there. So let's put the little reluctor wheel on the back and see what position it is in. I'm going to start here with the one that came off this motor. So this is the one off the Flex. And I apologize, it's really tough to see back here. But this should work. Okay, so let's rotate this around until it gets into its proper position. There we are, clicked in. So I'm going to use this little bolt here and then line it up right there. I'm going to do the same thing here. Got the other reluctor wheel on here. This is from the Taurus. Okay, got our mark there. Now we can compare. Okay, I got my two marks on there. And as I line them up, you can see that the openings are a little bit offset. So basically, we're trying to figure out if there's a difference in the crankshaft. If they're the same, we definitely want to put the Taurus reluctor wheel back onto this Flex motor. Okay, again, this is where you never want to throw anything out until you're totally done with the project. You oftentimes need to go back to the old parts to make comparisons. So we'll go ahead and rotate this crank until this journal here is pretty much dead center. And looks like about right there. So now we can go ahead and move here to the other side. And I put on the wheel that we had marked with the paint pen. And if you look down here, that yellow mark lines up exactly with that bolt, just like it does over here. Of course, that's upside down compared to this one. So anyway, that gives me pretty good assurance that these are the same crankshafts. So what does that mean? I'm going to take the Taurus reluctor wheel and replace the Flex reluctor wheel with it. So it's a good thing that we caught this. We're definitely going to need to use the reluctor wheel from the Taurus. Had we not, and used the one that came with this motor, or we would have some serious timing issues. It's very likely that the engine wouldn't even start, and if it did, it would probably throw all kinds of trouble codes related to timing. Next order of business is to take care of this coolant tube. We're gonna have to take all this intake apart and take it off and pull out the tube that's currently in here and replace it with the Taurus one. Well, I think I'll hold off till the next video to replace this coolant tube. And once this is replaced, I think then we can finally start working on the turbos and getting those back in. And then hopefully we won't have any other issues. Fingers crossed. You know that's not going to happen. There's always going to be issues. But anyway, hopefully we can get this thing back together and get it into the car in the next video. And hopefully try to turn it over and start it up. So anyway, till then, I'll catch you on the next video. Have a great day. Bye-bye.